Yeah.
All right, what do we have
So
on this
for
evening?
today, the first half I want to go over my quiz, and then the second half, my homework.
Okay.
So I sent two of them the pictures of the test already.
Okay.
Did you say
Did
that
you
your
say that
son
your
has a
son has a
Galaxy
Galaxy
S4?
S4?
Yes, he does.
Does he like it?
Do you like it?
He loves it.
All right.
He showed it to me briefly. I went and visited him a while back. Let's see. We got to flip this thing that way. Okay, where do we want to start here?
Let's start with the number 3. Yeah, that one.
Okay.
And I've already gone over this with my teacher, so some of the handwriting's hers and work and stuff, but I'm going over it again just to make sure I have it down.
Let's go through it without all of the notes.
Okay.
Well, that's going to be easier said than done, I guess. This is fine. Fit this in here. Okay, use the quadratic formula. So the first thing we want to do is get it in standard notation. Like that.
Yeah.
So what's A, B, and C?
A is square root of 3, B is -2, and C is 2 square root of 3.
Okay. So let's plug it in.
Be 2 plus or minus the square root of 4 minus 4 in parentheses square root of 3, and then in parentheses 2 square root of 3. All over 2 m square root of 3.
Okay, so let's simplify what's inside the radical first. So what is this equal to here?
It is equal to
What's this? Just this part here.
yeah, that's what I'm doing now.
Okay.
Oh wait, I forgot something. Hold on.
What's root 3 times root 3?
Root 3 times root 3 is root 9.
Which is?
3.
So that's the same thing as 4 times 3 times 2.
Okay.
Okay? So what I have in the square there is 24. So now let's rewrite it.
Be 2 plus or minus square root of -20 all over 2 square root of 3.
Okay? And then let's reduce square root of -20.
Be 2 plus or minus I, and then 2 square root 5.
And then again,
all the 2's simplify, so it would turn into 1 plus or minus I square root of 5 all over 1 plus with 1 square root of 3.
and again.
Mm,
In other words, we want to get it into A plus BI format. So we don't, there's two things wrong with this answer. It has a irrational denominator, and it's not split into two fractions yet.
You can multiply the numerator and the denominator by square root of 3.
Okay. So that gives me root 3 plus or minus what?
I square root of 15 all over 3.
All over what?
3.
Okay, and then one last step.
What is the last step?
Splitting it into two fractions. That being the first fraction, that being the second fraction.
So the first fraction would be square root of 3 over 3.
Uh-huh.
And then the second one would be I square root 15 over 3.
Yeah, but remember standard format is A plus BI. I don't know how much your teacher is going to insist that you have it exactly in this format. If she wants it in this format, then I have to make it square root of 15 over 3 times I.
All right.
In other words, this is A, this is B,
Okay.
when you get it in the final format. Let's see what we had.
All right.
Okay, we got something close to that. Must have made a math error or something. Okay, what next? Which one next?
Number 4 and 5. Change the lead on that. Yeah, there.
Okay, let's see. X squared over 2 plus 1 equals x over 3. Okay, what's our first step going to be here?
Get rid of the fractions, so we would multiply by 6.
I love it. What's
so
the
it would
next?
turn into
Go ahead.
be 3x squared plus 6 equals 2x.
Okay, next line.
3x squared minus 2x plus 6 equals 0.
And this must be a quadratic one or not? I mean, is this going to factor nicely?
No, this does not factor.
Okay, so let's go through the quadratic line by line.
A is 3, B is -2, C is 6.
Okay.
It'd be 2 plus or minus square root of 4 minus 4 in parentheses 3 and 6 all over 6.
Okay. Next line.
Under the radical, that is -68, square root of -68, all over 6. And now we have to simplify. 2 plus or minus I 2 root 17.
Okay.
And then in the next line, to put them into fractions, or you can reduce. So it turn into
You
x
can do that
equals.
in one step if you want. Let's just split it into two fractions and reduce at the same time.
All right. So the first fraction would be would it be 1/3?
Mm-hmm.
Plus or minus. The second fraction would be square root 17 over 6i.
What about the 2?
Oh, that turns into a 1. And then the 3. So
Okay.
sorry.
So what's the rest of it then?
Square root 17 over 3 times I.
Good. So you know how to do these. You must just be making mistakes.
I don't know. I just get to the test and then just blank out. I don't know what happened.
Really? Okay.
Yeah.
Well, let's look at 5. Now 5, we can maybe do a different way. Because even though it's a quadratic, we don't need to use the quadratic formula because of the format that it's in.
Could we just square root both sides?
Well, what's first step?
Move the 75 over.
Okay.
And then we can take the square root of 3y minus 5 and 75.
So our next line is what?
It would be, what goes into 75? That's square root.
What are your square roots? What are your perfect square numbers? Go through them from 1.
4 or 1, 4, 9, 16, 25, 25. So
Okay.
you could do 5 square root 3.
And there's only one thing missing from that.
Plus or minus.
Uh-huh. Now what?
Um,
Trying to isolate y.
so move the 5 over.
Okay. So what's the next line?
3y equals 5 square root 3 plus 5.
Let's put it in the same format that we would have it if we were using the quadratic formula, like that.
Okay.
Now what's the final step?
Divide everything by 3.
And that's actually a perfect final answer. Notice,
All right.
had we done it the hard way, in other words, had we squared that first, we would have had a y squared term, we would have had a y term, we would have had a number, we would have reduced it to a quadratic and standard format, we would have used the quadratic formula, and we would have gotten the same answer. Notice how much quicker it was to do it this way. 3 steps basically. The other way would have been at least 6 steps, a lot longer.
So when you see that square sign, you can almost always do square
Yeah.
both sides.
Yeah, in other words, if there is no obvious y term, it's the same thing as if I said to you, let's solve the following. that's a quadratic, but it doesn't have a middle term. It doesn't have an x term. So even though I could use the quadratic formula if I wanted to, I'm going to do it the easy way. Same thing I would have gotten had I used the quadratic formula. But I don't need the quadratic formula if I don't have a middle term with an x. Well, if you look up here, even though if we multiplied this out, we would have a middle term with y, the fact is we can solve this in exactly the same way that we solved this, because the square only applies to that term and then there's nothing in between.
Okay. Yeah, my teacher told me that quadratic formula always works. It's just not always the quickest or most ideal way to do it.
Right. Let's take a look at number 5 using the concept of substitution. In other words, if I let u equal 3y minus 5, then what I really have is u squared equals 75. U equals plus or minus 5 root 3, and since u is 3y minus 5, then 3y minus 5 equals plus or minus 5 root 3, and solve it as we did the other one, the same way. This concept of you don't need to actually do this substitution. We didn't do it when we solved it, but essentially we were doing that. We were substituting u for that. Because these can get more complicated. Had they stuck a middle term in here of 3y minus 5, then we would almost needed to use the concept of substitution in order to solve it. You had some problems like that at one of our sessions, I remember.
Yeah, there's one of these on the test on the next page that I sent you.
Well, in essence, this is kind of one of those. It's just you don't actually have to do this substitution. Any more on this page? 7 here?
Yeah, we can go over this.
Choose the letter that describes the nature of the roots of each equation. Okay. So how are we going to figure this one out?
Using the discriminant.
Okay. So what is our discriminant equal to on this? What's our discriminant?
For number 7?
Yeah, what's the general formula for the discriminant?
B squared minus 4ac.
Okay. So what is it in this case?
144 minus 4 in parentheses 9 and 4.
Okay. So I'm trying to figure out how you got this wrong. Oh, I see. Okay, you got it confused with irrational and rational. Okay, so let's see. The next thing on here is,
That equals 0.
Yeah, that equals 0. So how many solutions do we have?
It would be a real solution because it's not negative, and a double root because it's a 0.
Actually, when it's equal to 0, you have precisely one real solution. A. Real unequal rational, real double root rational. Excuse me. It's C. I didn't quite understand what they meant by double root. I've always been taught that if your discriminant is negative, you have 2 complex. If your discriminant is positive, you have 2 real. And if your discriminant is 0, you have 1 real. But it is true that it is multiplicity 2. So I understand why C is the correct answer. It's double root, meaning multiplicity of 2. But most of the time, people look at that as one real solution. Okay.
Okay.
It's not irrational. To be irrational, that discriminant would have to be a number that didn't turn into a whole number. that would be irrational. In fact, anything that doesn't turn into a perfect whole integer is going to be irrational.
So pretty much a not nice number.
Any non-perfect square number is an irrational number. It's a number that cannot be expressed as a fraction. In other words, it's a decimal that doesn't repeat. Okay, let's see. Let's open up. 8 is the next one?
Yes.
Okay, so we're just supposed to solve?
Yeah.
Okay, this looks like a quadratic in disguise. That's what I call these problems. Instead of solving them using substitution, I call it a quadratic in disguise. What's our substitution going to be?
1 minus 3x.
So rewrite it as a quadratic in u.
U squared minus 13u plus 36 equals 0.
And does this factor nicely?
Yes, it does. U minus 9 and u minus 4.
So u is equal. And now how do I solve for x?
You have to plug it back into the 1 minus 3 equation. So 1 minus 3x equals 9. Move the 1 over, and you get negative 3x equals 8. And then x equals 8, negative 8/3.
Okay. And
Then just do the same thing for the other one.
so 3 equals negative 3x, x equals negative 1.
I don't know how I got that wrong. I just blanked on the test.
Okay. Let's see, what did you do? You did the correct
That's not what I did on the test. That I reworked that.
Okay, so your handwriting is just what was crossed out here?
Yeah, that's what I was doing on the test. Yeah.
Okay. Okay. So you didn't recognize that as a substitution?
I did not.
Okay.
Which I don't know how, because we did like hundreds of those.
Right, we did. We had a whole evening where we did a whole page of these. That were harder than that one. A lot harder.
Yeah.
Okay. In general, do you feel like things are going a little better or not? In terms of your understanding the material?
No, they are.
Good. Good.
They are. It's just that this one test.
Because it feels like it to me. It feels to me like you're getting this stuff.
Yeah.
Okay, so number 9, what is that radical sign there? Oh, no, I see. Is the problem this?
Yeah.
Okay. So what's the next step?
You have to get. You can do. I think one of the methods that I talked about today when I met with her about it was you can let y equals x equal x squared.
Okay, so we're going to use u substitution or any variable you want, but I wouldn't use y. Only because you have so many equations where you end up with y equals a function of x that I don't like to use y when it comes to substitution problems. You can
Okay.
use any variable you want, though. I mean, I don't want to force you to use u, but it keeps things consistent rather than mixing things up. You can use z or v or whatever you want. Is there a particular variable you like to use when you're doing it?
I mean, I like you, so.
Let's use u then.
All right,
And
so
we picked
u
x
equals x
squared
squared.
because we're going to pick whatever the middle term is. Whatever goes with the b,
Okay.
that's what we pick for our u substitution. So what's the function as a function of u?
2x or 2u squared minus 3u plus 1.
And does that factor nicely?
No, I believe not.
Yeah, it should. 2u minus 1 times u minus 1.
Oh, wait, yeah, it does. Yes, it does. Sorry.
Okay, that's all right. I'm glad. I mean, the hard one is going to be when they give you one where you have to use the quadratic formula after you put it in u. So u is equal to 1. I can tell you what mistake you made right now on this one. You didn't put the plus or minus sign in the answer. So what's the next step to solve for x?
You have to plug the u back in, so 1 equals x squared, and then x equals plus or minus 1.
And then the
And
other
then 1
answer.
half equals x squared.
Okay.
And then 1 quarter?
No, we'll start off with the square root of 1/2. Right?
Yeah.
But that's not going to be an answer she likes as much as another one.
Oh, it's 2, isn't it?
What?
Isn't the answer x, when the x would be x equals plus or minus 2?
Well, first of all, this square root of 1/2 is the same as square root of 1 over square root of 2.
Yeah.
Which is the same as 1 over square root of 2. What's wrong with that answer?
Radicals in the bottom, or denominator.
Okay. So how do we rationalize it?
Multiply both sides by 2, or square root of 2.
So what do we end up with?
Square root of 4, which is 2 on the bottom, and then 1, square root of 1.
Okay, hold on. Don't make a error here. We're multiplying this by square root of 2 over square root of 2, right? In other words, we can't multiply just the bottom by square root of 2. That would be changing the value of the number. But we can multiply any fraction by the number 1. So our number 1 is square root of 2 over square root of 2. What does that give you as an answer?
Square root of 2 over square root of 4, which is 2 on the denominator.
That's the prettier answer than this. She might have counted that right, but deducted a point if you put it in the other format. But I'm guessing you missed it because you left off those. Yes or no?
No, I think this was the one that I didn't get at all.
Oh, okay. Okay. So this, okay, you treated it like a quadratic.
Yeah.
Okay. And you needed to use the u substitution. In other words, 9 is pretty much the same as 8.
Okay.
It is a it's a quartic because it's a fourth, but what you're looking for is for this term to be this term squared. And it doesn't matter what it is. In other words, it can be anything, is all it has to be is squared. In other words, if I wanted to really think up some tough quadratics in disguise, How about something like this? You see why that is a quadratic?
I think so.
What would you let u be?
1/3.
X to the 1/3.
X to the 1/3.
So now when I write this in a quadratic in u, what does it become?
U to the 1. Is it? Would it be U to the 1/3?
Well, it'd be u squared. In other words, 2/3 is, if I want to know how to write x to the 2/3, let's square both sides over here. So I have u squared is equal to x to the 2/3. In other words,
Okay.
this middle term is squared to get to be that. That's what makes it a quadratic in disguise. And that's all that you have to do, is if this first term is the square of this term, and then there's an additional constant, it can always be turned into a quadratic using u substitution.
Okay.
It can be a little trickier to recognize when it's like this, because not everybody recognizes that that is the square of that, but it is. Just like x to the 4th is the square of x squared. That's why we can use u substitution. In other words, if this problem was x cubed over here, can't use u substitution, cannot treat it like a quadratic. This
Okay.
problem becomes immensely more difficult to solve by merely changing that exponent to a 3.
Okay. And then for the 10 and 11, I got the equation right, which is the hard part, but I didn't know that because in the directions it says use your calculator, and we were supposed to graph it and just look at the intersection point to find x. And I didn't read the directions carefully enough, and I tried to solve it by hand, and it just didn't work out. But I got the equations right, but...
Okay, so she wanted you end up with a quadratic?
No, it's the above that. No, yeah, that.
This one up here? So,
Yeah.
what is
And you're
this?
supposed to put that in the calculator to graph.
Okay, do you know how to do that?
Now I do, yes.
So this is in factored form. So that's 12 plus 2x. So in order to graph this, what is this term here? 8 plus
8
2x?
plus 2x.
And it's all equal to 144?
Yep.
So you foiled these two together, and then you know how to put that into the graph calculator. When you said find the intersection, you want to find the zeros, really, right?
Yeah. It's like you'd put the 12 plus 2x.
Okay. You could find the intersection. In other words, you could put this in as y sub 1, this in as y sub 2,
Yeah.
and wherever they cross is the value of x.
Yeah.
That's what you wanted you to do?
Yeah.
Because the other way is to multiply these two out, form one big quadratic, and then find the zeros for that quadratic, or the solution for it. Either way, there's tons of ways to do it after you do that. Actually, there's tons of ways to do it. We just found 3. In other words, you can put 2 different functions where they cross, or you can set it all up as a standard quadratic equals 0 and find the zeros, or you can set it up as a standard quadratic equals 0 and problem solve it and find the solution in your calculator.
All right.
So there's numerous ways to find that one. Okay, the total surface
The
area.
11 was a big mess. I got it right, but it was a big mess.
Okay.
Wrong equation.
Because it's a cubic, right?
Yeah.
Yeah, because we're going to have this times that equals 50, basically. I mean, it's not that times that, because that's volume, but I know the formula for surface area. So you got the surface area formula right.
Yep.
How did you end up solving this? This is going to be a cubic. You were allowed to use your calculator?
Yeah.
So you ended up with a cubic function.
You put that where it's written, where it says equation and then the line, what I have written there, you do 2x times, in parentheses, 4x minus 3, times, or plus 2x times x plus 5, plus 2 times 4x minus 3, and so on.
Right. So you had to multiply that out?
Yeah, because the calculator won't take it unless you do it that way.
So you can input this directly into the calculator, like this way?
Yeah, you just have to put a multiplication sign wherever there's parentheses, so like after it.
And then does it produce the cubic polynomial? In other words, are you using the expand? Or do you don't have the expand on your calculator, do you?
I don't think so, no.
Well, on my calculator, I can put like 3 linear factors, and it'll multiply it out for me to get the polynomial. But I think that was
you have the one that we're not allowed
yeah,
to use.
I think that was missing from yours. So, okay, so you turn this into a cubic polynomial, entered that in as a function, and solved for the zeros. Is that what you did?
Mm-hmm.
All right.
Yeah.
That's the right way to do it. I mean, that's the only way you can do it. Okay. 12. We're missing a plus or minus.
Yep, that's the only thing.
Tell me how I can get my students to remember that. Because at least 70% of them have exactly the same problem. No, seriously, I don't know how. There's no little nice thing you can use, like a little rhyme to remember. I know that some students, they teach the quadratic formula by singing it to them or something.
Yeah, that's how I was taught.
Yeah. In fact, that's how, we all know our ABCs. I don't know which comes first, G or H. I got to say it. A, B, C, D,
Yep.
got to go through it like that. So how do we get you to know plus or minus? When it's the problem, as I see it, is the fact that when we write a radical sign, it's not plus or minus. In other words, if I say what that is, it's 2. It's not plus or minus 2. But if I have an equation where x squared is equal to 4, and I have to take the square root of both sides, that's where it becomes plus or minus. So maybe when taking the square root of both sides, always remember your plus or minus. Turn that into a song or something. But it always has to do when you're taking the square root of both sides. All right.
Okay.
I mean, I don't know how to. I wish there was some magic song I could sing. Let's see, we got a third one here, huh? Because actually, there's a lot of higher math, and you'll probably take it, where you really do have to remember things. Like in calculus, there's something called log poet, and it's an acronym that is used to memorize. The L stands for log, the P stands for polynomial, and so forth and so on. Stuff like that. You know what I'm saying?
Yeah.
That it'd be real hard to get through those maths without coming up with those little tricks for memorizing stuff.
That's actually the same thing we just did. I took 3 pictures just to make sure we could get all of it clearly, so we actually don't need that.
Okay.
But I have pictures for my homework tonight that I will send you at this very moment.
Okay. You ever heard of a Bitcoin?
No.
I'm just curious whether it's gotten down to high school yet. It's a virtual currency.
What is it?
It's a digital currency that somebody just made up based on a math algorithm. And it's gone from $10 per Bitcoin in January to $500 today. And it's a currency that somebody made up out of thin air. And now there are $6 billion worth of it on the planet.
Oh, I can't wait to get my new phone.
It'll probably have, what,
Only
13? How many megapixels will that have?
Probably 13.
13. It's not one of those. It's not one of those new 41 megapixel phones.
No.
Where do we want to start here? Like who could tell the difference between
Number
41 and 13? Number which one?
Yeah, honestly. 7, and we're supposed to go odds through 35.
What are we doing here? We are graphing each. You may wish to check your graphs on a computer or graphing calculator. Follow the method of example 2.
Actually, hold on. Let's not start at 7. Let's start at 20. Yeah, 25.
Okay. I was going to suggest graphing problems. Sounds like that's a pure calculator problem, but it sounds like there must be some method that they showed you that they wanted you to use also.
Yeah, there is, but yeah, it is a large calculator area unit.
All right, so we've got x squared minus 4x minus 3. For each function, find the vertex, its domain, its range, and its zeros.
So I've already done these problems, and I've been able to find the vertex, but I need help on the domain, range, and zeros.
Okay, let me ask you how you found the vertex.
I graphed it in my calculator, and then used that to the min and max to find it.
Okay. So this graphs like something like this.
It opens, yeah, it's move the vertex a little to the right, but yes, that is right.
Okay, let me move the vertex a little to the right.
Yep, that's...
Doesn't really matter for domain and range in terms of explaining what domain and range is. Domain is everything that x can be.
Okay.
If you look at this function, are there any values that would present problems? In other words, are there any values for x that cause you to divide by 0? Are there any values for x that cause us to take the square root of a negative number? Are there any values of x that, you know, can't be allowed to happen? You know, the first commandment of mathematics is thou shalt not divide by 0. So that's the first thing you look for. So in the algebraic equation or expression, it doesn't appear that there's any values of x that I can't put in there. I can put in minus 100 million if I want, or I can put in plus 100 million, or I can put in 0. So the domain would be what? Just by looking at the equation,
would it be all real numbers?
Uh-huh. Now let's look at the graph as to why that's the case. We are looking along the x-axis. Let's look as far to the left as I can and as far to the right as I can. Is there anywhere, can you see why it has to be all real numbers? In other words, x
No.
can be minus 100. It's just
Yeah.
it doesn't show on this graph because I don't have a wide enough paper to draw the true parabola out to its full extension. But this goes to infinity in both
Yeah, I was going
directions.
to say, doesn't it go to infinity?
It goes to infinity on the x-axis and it goes to infinity on the y also. So
Okay.
that's the way to analyze domain and range when you're looking at it. Now, just purely looking at the graph, what is the range, which is what y can do?
Y would be all real numbers as well, wouldn't it?
No. Do you see the values going below this point?
Oh, wait. It'd be numbers, range. Hold on, let me look at the vertexes.
What's the y coordinate of the vertex?
-7.
Okay. And is it greater than or equal or just greater than?
Greater than or equal.
Because it can be -7. So
Yeah.
what would the interval notation look like? Have you had interval notation?
No.
How do they want their answers? Like this?
Yeah.
Or like that? All reals?
Both of those work.
Okay. Interval notation would be for the range -7, infinity with a bracket, on the 7. In other words,
Yeah, we haven't seen that.
okay. All right.
And then what about zeros?
Okay, the zeros are the solution, or if you want, graph it and find the zeros. The same way that you graphed it and found the minimum.
All right, let me graph this real quick.
Okay? Yeah, make sure you can find the zeros on there.
All right, so I graphed it. Do you go to 0? I have on mine it's.
You go to analyze. I think you got to analyze.
Yeah, it's analyze graph, and then I have number 1 is 0.
Okay. And then it's going to probably say upper bound or lower bound as the first check and present you with a vertical line. Make sure that that vertical line is to the left of your left 0.
All right, I got it.
And then if you go up to your scroll pad, well, and hit enter to mark that line, and then use your scroll pad to move to the right of that first 0 on the left, and hit enter again, and it'll tell you what that 0 is. In fact, you might be able to do it all in one step. In other words, you might be able to put, I suspect you probably can, if you put your first line there and your second line there, it might give you both zeros in one step. I don't know. You could try it.
No, it didn't.
It didn't? Okay, so you got to do them one at a
It
time.
gave me the 1. Yeah, it's -0.646, 0.
Okay. And did I show you how to move your labels around? Sometimes you can get that picture of the graph with so many points on there that...
Yeah, I know how to do that.
Okay, good. You got to make that hand close and grab the label and move it. Don't need to so much on a problem like this, but I ran into a problem the other day. Somebody was using that calculator, and the function looked like this, and it said find this local maximum, and also the zeros. So we ended up, in fact, it was find this point, and the zeros, which are that point, and that point. So there were 5 points we had to find. So we had a ton of labels all over that graph. And without the ability to move them around, I wouldn't even have been able to read which ones went with which point. You know what I mean?
Yeah.
Okay. So that can be a really useful capability when you get more complicated functions. Okay, so let's look at 26. We got 27?
Yeah, we're going odds.
Okay. What is 27? Can you read it?
Oh, sorry, the picture cut off. Negative x squared minus 2x plus 8. Yeah, it's written backwards, but I just flipped it.
Yeah, that's fine. That's fine. Okay. So that is f of x.
Yeah.
What's the domain on the domain on all parabolas is going to be the same. Because they all are either going to look like this or they're going to look like that. And in either case, x goes to negative infinity or positive infinity.
Can't they open to the sides?
Well, they can. You've had some conic sections, I can see. It is actually a parabola, but it's not a function when it opens like that. It's technically a parabola by the definition of conic sections, but it's not a function because it doesn't pass the vertical line rule. So it can't be treated as a function.
Okay.
Notice that it does change the domain. In other words, you're right. A parabola that's oriented like this does not have all reals as its domain. In fact, the range would be all reals. The domain, it would be much the same as the range of if it were upright. But anyway, as long as it's y equals x squared, it's always going to be a parabola that's either up or down. So you automatically know that your domain is all reals for quadratics. The range is what? We know you plotted this, so it looks something like that.
The domain, I have the vertex at negative 1, 9, so the domain would be x greater than or equal to 9. Or less than or equal to 9.
Y, or f of x. Let's not introduce y since they didn't introduce it, but f of x is what the range is referring to. So what is it again?
Is that correct? All numbers less than or equal to 9.
Yes, that is correct. Okay. All right, so I think you got that. 29, just going to be a question of finding that vertex.
So the vertex is 1, negative 6.
Okay. So what's the range?
Hold on, let me write the domain real quick. The range is all numbers equal to or greater than negative 6.
Good. Okay. And the zeros, you know how to do that. Does your calculator give you domain and range? Is that on there?
I think it does, but I haven't discovered it yet. I think it does. I'm not positive.
Let me take a quick look.
I bet yours does.
Yeah, I would think it would. Let me pull up my menu. Let's see, where's it going to be? Under Analyze or under View, maybe? No, View doesn't give it. Analyze doesn't appear to give it. Yeah, I don't know how to do it if it does do it. I'm amazed it doesn't do it. I got to believe it probably does. I just don't know how.
Yeah.
When I discover how, I'll let you know.
assuming mine has it.
Yeah. So how are you going to do 31?
31, the vertex is 1 comma negative 72. So the range is all real numbers greater than or equal to negative 72.
How'd you get that as a vertex?
I might have graphed it wrong. I'm not sure, but that's what I got when I put it in my graph. I'll put it in again right now.
Do you put it in after multiplying or before?
No, I do it before.
So you do put it in like this. So you define the function down below like this.
Yeah.
Oh, okay. The only reason I
Instead,
say that
it
doesn't
makes it
sound
easier to
right,
do it.
maybe that is right. Let's see. I was looking at minus b over 2a, and it didn't
Yeah,
seem
that's
like.
what it said again.
Okay. Okay. No, it
But
must be right. It must be right.
my teachers told me that if you put it in that way before simplifying, it eliminates the risk of you making a mistake simplifying on a harder problem.
Yeah, no, I agree totally. If you can put it in like this, I would always do that, because why take the chance of making a mistake on the multiplication?
Yeah.
In other words, we can always make a mistake here. So if you can input it like that, in other words, you're saying f of x is equal to this, huh? You can do that on that calculator. I haven't ever tried
Yep.
that. So, okay, good.
You just have to put a multiplication sign in between the x minus 7 and the x plus 5 when they're in parentheses.
A multiplication sign being the dot.
Yeah, you'd have to, it'd be 2 and then in parentheses x minus 7, close parentheses, and then hit the multiplication function and then in parentheses x plus 5.
Okay, so it doesn't recognize
'Cause it won't take
multiplication
any
automatically.
time.
Okay.
Yeah.
All right. So I think you know how to do these. Is there any here? We only have like 2 minutes left. Is there any one that you're not sure how to do? You're going to do all of these in your calculator, right?
Yeah.
Okay.
Maybe I'll do better on this quiz because this one deals largely with the calculator.
Okay. Good. Good.
Oh yeah, since we only have a couple minutes left, can we go ahead and schedule for Thursday because I have a quiz on Friday?
Sure. Yeah, I had most of Thursday. I think I'm scheduled from 5 to 7. No. Yeah, hold on. I'll let you know here in a second. Let's see. You're looking for a half hour or an hour?
Let's do an hour.
Okay, you can go before 5:30 or after 7:30.
Let's do 7:30 to 8:30. Sound good?
Uh-huh.
All right, let's do that.
Okay. I'll talk to you Thursday night.
All right, thank you.
All right, Jackson. Bye-bye.
Bye.